Okay, welcome back. Since Mental Ray 3.6, a couple of major new features have been introduced with Mental Ray. In this case, Mental Ray from Maya 2009, which comes with Mental Ray 3.7. Okay, these two major features are Importons and irradiance particles. Okay, in this video we're going to talk about Importons. Later we'll talk about irradiance particles. Right now we'll focus our attention on Importons. So what are Importons? Well, Importons are a new indirect illumination algorithm that are based on importance. Importance that's based on what the camera sees. Instead of computing something that is scene-wide, something that's computed for your entire scene, Importons focus on just what's important. Just what's in front of the camera, just what the camera sees. That way you can reduce rendering time. And also, the key thing to Importons is that they can reduce the size of your photon maps. Now, Importons don't work by themselves. It's not like saying final gathering or global illumination. Importons has to work with something else. Now, Importons can work with either the new irradiance particles or they can work in combination with global illumination photons. That's what we're going to look at now. So let's open up an example scene. And the scene that we're going to open up is called 08 Importons Start. So let's open up that scene, hit Don't Save, and we'll go ahead and do a render. And what we have here is a pretty simple scene setup. It's a simple room with a hole there in the ceiling and a Mental Ray area light shining through there. Okay, and we already have the Mental Ray renderer loaded up, as you can see here. If not, make sure it's loaded up. Alright, so right now we don't have any type of indirect illumination. You can see that the ceiling is pitch black, which is no good. So what we're going to do is take this light, open up its attribute editor, go to the Mental Ray settings, go to caustic and global illumination, and we're going to go ahead and activate this emit photons parameter. Let's open up the render settings as well. Go to indirect lighting here. And let's turn on global illumination. And let's collapse final gathering. We won't be using final gathering anymore. And I'll leave the default global illumination settings. Let's go ahead and do a render here. And remember that we still have that output window. An output window is going to give us very useful information here. Let me go ahead and stretch this out a bit. A little bit better to work with there. And we're going to be using this output window while working with Importons. So, there's our global illumination. Okay? We don't have a lot of photons in this scene right now, but the global illumination looks really, really nice. Adds a lot to the scene. Now, let me minimize the output window here. And let me go down to Photon Map here in render settings and turn rebuild off. That way now it just renders out the image as opposed to calculating global illumination every single time that I render. Let me do an IPR and I'll render out an area about that big. Let me close the render settings. I'll also close the area light here. And as I rotate my camera around, I can see it update and it's rendering the back of the room. Now global illumination renders out for the entire scene. Okay? Because of that, you can end up with very big global illumination photon maps. Alright? So that's what I'm going to do. I'm going to open up my render settings. I'm going to turn rebuild back on. And I'm going to create a photon map. I'm going to call it simple room.ph map. Okay? And another thing is if I close that, let me close my render settings as well. Let me open up the attribute editor for my area light, which is the only area light in my scene. This area light has already been set up with 4 million photons. The photon intensity is only 4,000, so it looks pretty good, not too bright. But right now there's 4 million photons. That's a lot of photons. Let's use something a little bit smaller. Let's use something like 1 million. Okay. And let's do render. Okay. Calculated those photons pretty quick. Alright, there we go. So we have a lot of light blotching in this scene. Doesn't look too great. If I go back to my file browser here to my project directory, and I go back to the render data folder, I go to Mental Ray, and then I go to Photon Map, I'll notice that here's my photon map, simpleroom.ph map. And right now it's 20 megabytes, which is not really that big. So instead, let's go with 4 million photons. Let's render that out. You can see the photon emission is not going very slow. It's actually going pretty fast. And there it goes. 18 seconds, not too bad. If I look at my photon map again, my photon map is now 80 megabytes. That is pretty big. Pretty big photon map. It's definitely going to become a bottleneck if I were to render this on a render farm, and that photon map has to be transferred back and forth from the master to all the slave render servers. That's going to really slow things down, and it's going to congest the network traffic. Okay. So with that in mind, how in the world could we reduce the size of that photon map from 80 megabytes to something really small? Well, let me close this. Let me open up the render settings. If you remember, there's this merge distance parameter for the global illumination. The problem with using merge distance is, yeah, it'll reduce the size of the photon map, but A, it won't reduce the size of the photon map by much, and B, it creates even more blotching in your photon map. So it's pretty counterproductive. It doesn't work out too well. So what can we do? Well, that's where Importons comes to the rescue. If I come down here to the Importons in the render settings, you see that they're off by default. Okay, I'm going to turn them on. And you see that we have a very few amount of parameters here to adjust, not many parameters. Alright, the merge distance works very similar to the merge distance for the global illumination photons. Because I don't want to merge any of these Importons together, I'm going to leave the merge distance alone at 0 to keep it off. And over here, I have a density parameter. The density parameter is extremely important. The density parameter is what makes the difference between your render taking seconds, minutes, or hours. Very important parameter, okay? The default is 1, and the slider is all the way over here. That can be misleading. Someone who's new to this will come in here and think, oh, well, that's a pretty low value. Let me crank this all the way up to something like this, maybe 50, maybe even to 64, see what that does. You do not want to do that, okay? The default setting of 1 represents that there'll be 1 Importon fired for every pixel on the screen. That brings me to something else, another point. Importons are not just view dependent, they're resolution dependent as well. That means that Importons are dependent on the resolution of the image that you're rendering out. Right now you can see this image is 640 by 480. That means that right now at a density of 1, there's going to be 1 Importon fired for every pixel on this in this image. So if I open up, say, a calculator, I can do the math. 640 pixels by 480 pixels equals 307,200. That means if I have my density set to 1 and I render this out at this resolution, Mental Ray is going to calculate 307,200 Importons. So let me close that and let me show you what it is that I'm talking about. If I go ahead and hit render, you notice down here in the status bar it said Mental Ray Importon emission. If I open up the output window, it says collecting Importons. The more Importons you fire out in your scene, the longer the render is going to take. That's why that density parameter is so important. And over 300,000 Importons is actually a lot. Unlike with global illumination photon mapping, where you have to use millions and millions of photons, and you can render out 2, 3, 4 million photons in just seconds, you can't do the same with Importons. You can't render out 4 million Importons in the same amount of time that it takes to render out 4 million regular photons. So keep that in mind. What you want to use is small numbers of photons, not too much. 100,000 is good, 200,000 is good, 300,000 is really good. In some cases, it might actually be overkill. You want to start off with small numbers during test rendering, like 20,000 Importons, 10,000 Importons, even up to 30,000 Importons. Okay? Now you can see that it finished collecting Importons. Now it's optimizing Importons that it has collected. And the reason it's taking so long is because my density parameter is set to 1. So 1 is overkill. The default parameter of 1 for the density is actually overkill. So imagine if you would have gone in there without even knowing or having experience with Importons and put that density parameter to something like 64. You'd be here forever rendering. You would never finish rendering. You'd be here forever waiting for the Importon emission to complete. Okay, so there we go. It's still calculating these Importon emissions, and it is a lot of Importons because, of course, we're using a density of 1. Okay, pretty much finished calculating the Importons. Now you can see in the lower left status bar here of mental ray, it says mental ray photon emission. So the Importon emission has ended. It's collected all the Importons it needed. Now it's rendering out the photon emission. You'll also notice something else. And that is that when you're using Importons, especially when you're using a lot of Importons, the photon emission actually slows down and takes longer to render. So that's one of the downsides to using Importons. But there are 2 main upsides to using Importons that you're going to really, really like. And one of them is, and you'll see in a moment when this finishes, how it's going to reduce the Photon Map. You get to see that in a moment as soon as it's done. Almost done here. Come on, just a little bit more. Keep going, little guy. Come on, there you go. And it's practically done. There we go. Perfect. Okay, look what happened. The light blotching pretty much went away. Very good. Now, it took 3 minutes 55 seconds to render that, which is not really a really long time, but much slower than what we're used to. Now let's come up here to the output window, have a look at some of these stats and things over here. Okay, so over here it basically said there was a 4 million photon. Edit that video starting in 3, 2, 1. There was originally a photon map of 4 million photons. Okay, that changed. If you come over here and see, you see that it says that the area light emitted all these photons, so on and so forth. You know, there was over 400,000 photons, as you can see here. I'm sorry, not 400,000, 4 million, about 4.2 million. Now, what happened was the Importons came in and reduced that number down drastically. And to prove it to you, I'm going to go down here to my Photon Map browser, and here's my Simple Room Photon Map, which is now under 6 megabytes. It's only 5.78 megabytes. The Importons took an 80 megabyte photon map for global illumination and reduced it down to only 5.78 megabytes. 80 megs down to less than 6. That's a huge optimization. That's amazing. That's incredible, in fact. The fact that mental ray, that these Importons could take a photon map that was almost 100 megabytes, and reduce it to only less than 6 megabytes is simply incredible. And that optimizes things for you and makes it a lot easier in your render farm when it has to be transferring that huge photon map around. Much easier for a render farm and a local network to transfer over a file that's less than 6 megabytes, as opposed to a file that's 80 megs. Okay? But this density parameter was too high. So what I'm going to do is I'm going to lower it to something like 0.2. Okay? And I'm going to go ahead and I'm also going to reduce the number of photons in my scene. So I'm going to open up the attribute editor for the light. I'm going to reduce the number of global illumination photons to about 1 million. Close that. And I'm going to render this out again. Now you notice the Importon emission went by really, really fast. If I open up my output window, see it's collecting Importons, and in a moment we'll get to see how many Importons were used in the scene. And now we can see we're using much less Importons. As you can see, it's already doing the mental ray photon emission, and the photons are being calculated much, much faster this time. And there we go, we got ourselves a really good result. If you notice, there's no color blotching. You also notice something else, and I'll show you again. So you can do a little double take there. Let's go back up here. our photon map from 1 million photons was reduced drastically. See, right here, the Importons optimized our global illumination map and reduced it from 1 million photons to about just under 60,000 photons. Now, you're probably thinking, wait a minute, 60,000 photons? If we render this thing out with 60,000 photons, it's going to look horrible. Let's go ahead and let's do that. Let's open up the attribute editor for the light. Let's go with 60,000 photons. Let's render this out. And actually, let me cancel the render. I have to render this out without Importons. So we'll hit escape to cancel the render out. Okay. Let's go back to the render settings and let's turn Importons off. Let's render again, and there we go. Now, this is with global illumination only, no Importons. Okay. It took only 2 seconds to render, but there's a lot of color blotching. So we're going to have to add and render this out with about 4 million photons for it to look good. Okay, and then that's going to take a long time to render anyway. So a 2-second render, but we sacrifice quality. Look at all this light blotching everywhere. Light is not very physically accurate, doesn't look too great. So I'm going to save this image out. I'm going to turn Importons on. Okay, let me turn the photon accuracy up to about 1,000. Or actually, you know what? For the sake of image comparisons, I'm going to leave it at 500. I'm going to close this. And down here, I'm going to go ahead and increase the amount of global illumination photons to 1 million. If we go to our photon map, it was about 1.2 megabytes with 60,000 photons, which is not very big. It's very small, but it's a very nasty photon map. Doesn't look very good. So now let's go ahead and let's render this out again. This time with Importons. If you want, you can open up the output window so you can monitor what's going on there with the Importons and stuff. Okay, just finished calculating the Importons. 120,000 Importons. And the reason it did 120,000 instead of over 300,000 was because I lowered the density of the Importons from 1 to 0.2. So it's almost done doing the photon emission. Okay, now it's done. There we go. Took 35 seconds as opposed to 2 seconds, but a huge difference. And if we go to the photon map, we'll notice that the photon map is actually less than before. It's now 1.18 megabytes. So it's actually a little bit smaller than it was before. So the Importons took a photon map of 1 million photons and made it smaller than a photon map by itself of 60,000 photons. On top of that, it actually made this render look better. If we go over here to the right, here it is without Importons, just photons, just global illumination, 60,000 photons. This is what it looks like. Very nasty, unacceptable. If we go to the left, the blotching is gone and things look more detailed. If we look at the corners of the room, like right here where the wall meets the floor, and you look at this image with the Importons, this one looks much more accurate. It looks much more realistic, looks much more accurate. These details in the walls and the ceilings and the ceiling are much more defined than here. Here they're not very defined. You barely even see a line. Here you can see the line perfectly defined. The lighting and the shadows looks excellent. And that's using a very low Importon setting. If we close this attribute editor, open up the render settings, we'll notice we're using pretty low settings. We're using only a density of 0.2, okay? Which is pretty low setting, but as you can see, it's pretty decent and produces excellent results. And on top of that, you get the added benefit of a smaller photon map, okay? Now the max depth, what's the max depth? And I'm not going to go over the merge distance because the merge distance is pretty much the same thing as the merge distance for the photons over here. Basically what it's going to do, it's going to look at the Importons, and any Importons that are within the distance you define here, it's going to merge them together. And that's just going to help to reduce the amount of Importons. But I don't want to do that because the Importons are here to help out the global illumination. I don't want to hurt the Importons in any way. So I'm not going to use the merge distance at all. I'm going to leave it at 0 to turn it off. Now the max depth is pretty interesting. Right now the Importons are working with one diffuse bounce. That is, the Importons are going into the scene and they're creating indirect illumination with one bounce. But I can change that. I can take the max depth and I can increase it to 1 extra bounce, or I can do 2 extra bounces. Now usually what you want to do is you want to do about 2 for the max depth. That way your Importons bounce around and you're seeing enough. Here's a problem with Importons. Let me put that back to 2. What I'm going to do is turn Rebuild Photon Map off, and I'm going to rotate the camera to look at another part of the room. Okay, like this. And I'm going to render this out. Notice something? This doesn't look very good. If you notice, there's this strange line of light. That represents what our camera can see. If you remember earlier at the beginning of the video, I mentioned that Importons are view dependent. They work based on what the camera views. If something is outside of the view of the camera, it won't render properly. That's one of the limitations of Importons. We can fix that to a certain degree, however, by using the max depth parameter. Okay, so this is what it looks like. Let me go back to the first image and remove it. I'm going to save this image right here. I'm going to rotate my camera again to look back at this point of view right here. If I render that out again, there we go. And if I render this one on the right, or just move this scroll down here, scroll bar down here to the right, so I can see this. I can see it's very dark and lighting didn't really reach this area back here. What I can do is I can increase the max depth to something like 2, and something even better would probably be about 4. Now, every time you increase the max depth, the number of Importons are going to increase as well, because there's more Importons being created. Now Importons are bouncing around objects at least 4 times in this scene. That's going to create a substantially higher number of Importons, which means that it's like increasing density. You're just going to end up with more and more Importons, which is going to slow rendering down. You're going to slow rendering down, but you might end up with a much better result. So let's actually do that. Let's turn Rebuild back on, and with max depth set at 4, let's go ahead and render that out again. If you open up the output window, you're going to notice here there's going to be extra calculations being made, and that's because of the extra bounces from the max depth. And you can see right here, optimized 100,000, then did 124,000, and it will do more. Okay, it didn't take too long to render, only about 34 seconds. Now what I'm going to do is I'm going to minimize that output window. I'm going to rotate the camera again to look at that dark spot, and I'm going to render that out again. Oh, and I made a big mistake. I forgot to freeze the photon map, so I have to cancel this. Go back to the first view. I could do that easy. If you use the left and right bracket keys on the keyboard, you can go back a camera view. So use the left bracket key to go ahead and go back to the previous camera view. And I'm just going to have to go ahead and render that out again. I have to rebuild the photon map. Sorry about that. Happens. Sometimes you get caught up and you forget about simple little details like that. There it goes. It's not taking too long though. I mean, it's just about, 34 seconds was the previous render. So this one should be the same thing, about 35 seconds. It's actually pretty quick. Okay. And there we go. Okay, it took about 35 seconds. All right, this time I'm going to remember to turn Rebuild off. Okay, perfect. Now let me rotate the camera and look at this dark area again. And let's render with Rebuild turned off. And now we can see we're still not getting a good result. If we look over here on this one on the right, and we look at the one on the left, we're still not getting a great result, as you can see here. We can see some of the light is spilling over into the dark area, but it doesn't matter. It's still not helping. So that's one of the limitations of Importons, is the fact that you're pretty much limited to what the camera sees. Now we have this traverse option down here. What traverse does, and it's on by default, is Importons have the ability of hitting an object and stopping dead in its tracks. So they can hit a wall and stop there. But you can also tell Importons to go through objects. So they'll trace right through a wall, right through a piece of furniture, a table, whatever it is that comes across their way, whatever 3D geometry there is, it can actually go through it if we turn this traverse option off. Let me actually go back to my first view, hitting the left bracket key on the keyboard to do that. Okay, I'm going to turn rebuild back on, and this time I'm going to turn traverse off. I'm going to go ahead and render this out. You can watch the output window here. Okay, so this is what it rendered out. Actually rendered out a little bit faster, 26 seconds this time. I'm going to turn rebuild off. I'm going to rotate my camera to look at that dark area, and I'm going to render again with the map frozen. And you can see it still continues to render in that fashion. This is just because of the way that Importons work. Importons, as I said, they're going to do this. This is the way that they behave. They're based on the importance of what's in the view. That's where the name Importons is derived from. It's a combination of the word importance and photons. So you end up with Importons. If you want Importons to bounce around in your scene, which you can do, we can do that by just, we can turn traverse on, or we can leave it off, however we want. And we can turn the max depth to high numbers. In this case, 4 is pretty good. I don't really want to go over that because it's really going to slow rendering down. If we want these Importons to bounce around in our scene, we have to do a couple of things. We have to first give it enough max depth so it bounces around enough times. Okay. The other thing we have to do is we have to increase the density. We just need many, many more Importons. If we don't have enough Importons to bounce around in the scene, we're not going to end up with, well, we're going to end up with something like this. So if we wanted to, we can increase the Importons to, say, a density of 1. Let's go back to our first camera view here. There we go. I'm going to turn rebuild back on, render that out again. And this time the Importon emission is going to take a pretty long time because we're going with a high density here. The density of 1 Importon per pixel. So what I'm going to do is pause the video and skip ahead here so you don't have to watch this. Okay, I just want to come back to show you something really quick. As you can see in the output window, it did a whole bunch of different bounces of Importons. You know, 100,000, 200,000, 300,000, and it kept going all the way to, and we ended up with, up here we can see there's over 1 million Importons. That's a ridiculously high number of Importons there. Let's go ahead and minimize that. I'm going to turn rebuild off, and you can see the result we ended up here was a bit splotchy. Doesn't look too nice. Let's go ahead and rotate the camera here a bit, and we'll render out from here. Now we can see that the result looks a lot better. It's still kind of dark right here, but in all honesty, it looks pretty dark like that when you use just photons by themselves. But you can see we don't have that nasty line like we had before, and it looks a whole lot better, as you can see. So we were able to let these Importons kind of bounce around in our scene, and because we fired over 1 million Importons, as opposed to using only about 120,000 from before, we were able to get a much nicer result behind the camera. Of course, Importons are not meant for rendering behind the camera. They're meant for, they're view dependent, they're importance driven algorithms. It's an importance driven algorithm. It's designed for things that are in front of the camera, things that are going to be viewed in front of the camera. So if you're trying to get more of this room, one thing that you can do is you can move your camera back. Let me go to shaded mode here. If I zoom in enough and I place my camera about right here in the corner of this room, so I can get, and let me close that, so I can get the most of this room that I can, that's going to work better. So the trick is to get the camera placed in a strategically smart position in your room so you can get those Importons. So you can get the most out of those Importons, so you can render them out the most efficient manner. If you render out from here, you'll get a much better result than when we render it out from over here, right in front of this window in the ceiling. Okay, so I hope that makes a lot of sense. That's Importons. I'm going to end this video here, and I'm going to, in the next video, we're going to get into irradiance particles and how that works.